In this example, we have been asked to find the zeros of this polynomial function and state their multiplicity. We have also been asked to determine the degree and the end behavior of this polynomial. Now, first of all, notice that this is kind of a special problem because the right-hand side of this problem is already in factored form. I don't need to multiply everything back out because that would be going in the wrong direction. To find the zeros, I know all I would do is replace f of x with 0 and then try to solve for x. This already being factored means finding the zeros are almost immediate. In other words, the first thing I would do is think about when would this factor equal to 0. Well, the negative 9 in the front doesn't make a difference. The square on the x doesn't make a difference. The only way that that term would be 0 is if x were 0. On the next term over, wondering when this is 0, the cube doesn't make a difference. The only thing that makes a difference is the x minus 4. Well, if x minus 4 is a factor, then I know x equals 4 is a 0. Likewise, on this last one, I know that because x plus 1 is a factor, then x equals negative 1 is a 0. So our zeros are x is 0, x is 4, and x is negative 1. For each one of these, I have been asked to give the multiplicity. The multiplicity comes from the power on my factors. On the x, I have a power of 2, so its multiplicity is equal to 2. For the x equals 4, 0, I have a power of 3, so the multiplicity there is 3. And then finally, for the x equals negative 1, the understood power on that factor is 1, so the multiplicity there is 1. The significance of the multiplicities is if we were to graph, the multiplicity tells us what the graph does at that particular 0. The first multiplicity being even means that the graph would actually turn at that value x is 0. The next one, the multiplicity being odd, would mean that the graph actually goes through the number 4. And then finally, on the last one, the multiplicity being odd also means that the graph would go through at negative 1. This will make sense to us more later on, but I need to go ahead and tell you now so that you can be thinking about it. Now, our degree usually comes from the leading term of a polynomial. Technically, this is not in polynomial form. Polynomial means strictly a sum or difference of terms. Here we have a product of terms. So this is actually not in polynomial form. However, we can still figure out the degree by adding the multiplicities. So in this case, if you have something that's factored out, to determine the degree, add up the multiplicities. So in this case, if we were to add the multiplicities, 2 plus 3 plus 1, we would get 6, and that would be the degree of my polynomial. Okay? Now on this one as well, the end behavior is also determined by the leading term of my polynomial. Well, this original expression not being polynomial in nature makes the end behavior a little bit harder to think about. However, if we know what the degree is, then we would know that this is for sure something x to the 6th power if we were to actually multiply it all out. Then the only thing that we really need to know is, do we have a negative or a positive in front of that x to the 6th? Well, look here, and y'all see that we have a negative 9 in the very front of this entire polynomial, or this entire expression. And so there, all we need to know is that there's a negative in the front. I'll go ahead and write negative 9, but the only thing that's important is that it's negative. That being the case, we basically have a negative times x to an even power. That means that the end behavior, it being even, means the ends are both pointed in the same direction. It being negative in front means that they would both be down.